The sixth question that we have is a very important question from IIT JEE point of view. This is because this will teach you how to interpret graphs, which is very important, and also to remember the basic formula very correctly. So in this question, we have been given a graph of y versus x at t is equal to 0 seconds for two waves A and B. This is the wave A and this is the wave B. Now we need to find out the ratio of intensity of the two waves when they are traveling in the same medium. The medium in which they are traveling is same. So for finding out the ratio of intensity, we should know the formula of intensity, that is equal to rho VW Vp square. That is density into velocity of wave into velocity of particle whole square. This actually comes from, or rather you can take I average intensity. This is equal to average power upon, the average power is equal to mu VW A square omega square upon 2, and the area comes here. This becomes 2A. Therefore this is the formula for average intensity. Now mu upon A is nothing else but mass per unit length upon area, that is equal to density, that is equal to rho VW A square omega square upon 2. You should remember all these formulas. The formula for average power is equal to mu VW A square omega square by 2. The formula for average intensity also you should remember rho VW A square omega square by 2. And this is the intensity at any point of time, at any point, that is equal to rho VW into velocity of particle whole square. VW is the velocity of the wave. You should remember these formulae. Now we see that the intensity average is directly proportional to A square F square, because omega is equal to 2 pi f. Therefore we get a term of A square F square. Now rho and VW are dependent on the medium, which will be same for both of them. Therefore it is proportional to A square F square. Generally what do students write is that they directly write intensity is directly proportional to A square, and they solve the question using that and they get the wrong answer. Why? Because this is true only when frequency of two waves is same. Which is not the case over here. Therefore we cannot use this formula now. What we ought to use now is intensity is directly proportional to A square F square. So for solving this question you are required to remember the basic formula very correctly instead of the derived formulas. And if you remember the derived formulas, always remember the condition behind the derived formula. So we now know that intensity is directly proportional to A square F square. Therefore IA upon IB is equal to amplitude of A, that is equal to whole square, that is 25 upon 9 into frequency of A upon frequency of B. Now to find out the ratio of frequency, you have to interpret this graph very properly. Now you see that half a wavelength for A is equal to one full wavelength for B. Therefore we know that lambda f is equal to V. Now by this formula, the lambda of A is double the lambda of B. Now the velocity of both these waves is same because they are traveling in the same medium. The velocity of the wave is dependent only on the medium, and therefore the velocity for both these waves is same. Therefore the double lambda for A leads to half the frequency for A. Therefore the frequency of A is half the frequency of B. Therefore the frequency of B is double the frequency of A. Therefore this can be written as 2FA and this whole square. Therefore we can write this as 25 upon 36. So the ratio of intensity of the two waves is 25 upon 36, which is our final answer.